Hi, in this recording we're going to go over our section 2.5 notes. So make sure you have your graphing calculator out. We're going to be using that a lot. We're going to be talking about some linear regression and some quadratic regression. So what regression means is that we're going to have some data points, and you could think of making a scatter plot. And we could have something like, let me draw a picture. Okay, so we have our xy coordinates, and maybe we have data points that give us different points that we could plot. Okay, and we want to find, if they kind of line up in a line, we want to find the line that best goes through them that we could use to estimate other points. Or we could have something maybe that the points line up in something that looks more like a parabola, and we'd want to find a parabola or a quadratic function that best went through them. So that's what we're trying to do here. Now, just kind of a thing to get started, turn on your graphing calculator, and you will only have to do this once, but I want to make sure you have everything you need. So I need you to go to second and then the 0 button for the catalog. Okay, and then you're going to scroll down quite a bit to the D's. And we're looking for something that says diagnostic on. Okay, so this says diagnostic on. You're just going to put enter and hit enter one more time. And now that that's done, you don't need to do that every problem, just once. Okay, so like this says, sometimes we'll have data points from a specific situation, and we'll want to see if we can model the data with a line or a quadratic function. Okay, so finding this model, finding something that lets us estimate it is called regression. So when the data values form a line, we do linear regression. The line that we get is called the least squares regression, or the line of best fit, and our calculator will give that to us. The calculator will also give us an R value, and that R value is called the correlation coefficient. If we have a line with a negative slope, it's going to be a negative R value, and if it's a line with a positive slope, it's going to be a positive R value. And they're always going to be between -1 and 1. It's going to be a decimal. And the closer it is to -1 or to 1, so like -0.95 or positive 0.95 or better, the better it is. Okay, so here's what we're going to do in our calculator, and we're going to go through an example of this in just a second. We're going to have data values here. We're going to put this top line into an L1 and the second line into L2. Now to get there, here's the steps. You're going to hit the stat button, which is right here. Okay, and you're going to hit enter for edit. Okay, now if you need to clear stuff out, you'll hit the up arrow to where it's covering the top, hit clear, and then enter. So again, up arrow, clear, enter. Okay, so now mine are cleared out, and we're going to come down here, and here's census data for Licking County. So we're going to put in L1, this first line, we're going to put in our years, 1980, 1990, 2000, and 2010. Okay, and then in L2 we're going to put our population. So 129,81, 128, 300, 145, 491, 166, 492. Okay, now to get our line, now if you want to see this, if you hit y equals and you make sure your plot one's on, if that's not on, just go up and hit enter. Okay, and then I'm going to hit zoom. I'm looking for the one that says zoom stat. Hit enter. Okay, here are our points, and you can see they kind of make a straight line. Now, to see what line they give us, you're going to hit the stat button again. You're going to use the arrow button to go over to the calc menu, and you're going to choose number 4, which is linreg. Okay, now yours might just go back to the home screen and say linreg. That's fine. You're going to hit enter. I'm going to go down here and hit calculate. Okay, and this is what you should see. So it tells us that our equation of the line, which normally we call it in class mx plus b, they're just using an a instead of m. So we're going to put in a number for a and a number for b. So we're going to write our line as, oops, I need to bring this up. Okay. As y equals, we'll put our a value, 1537.24, and then x, and then plus our b. Now our b is negative, so we'll say minus 2926477.8. Okay, so that's our least squares regression, or our line of best fit. Does it fit the data well? Well, so we look at our R value. Our R value is 0.98, so that since that's pretty close to 1, we would say yes. So since R is 0.98, if it was something like 0.5 or 0.75, we'd say not really. So the slope here, the slope of our line of best fit, is this number in front of our x, the 1537. And when we say interpret it, we want to know what that means. Now I'm not going to write it with the pen on these notes because it's hard to write on the computer, but what this line means, so since this is talking about years and the population, this is saying our slope is our average rate of change, as we've talked about in class. This is saying on average, about 1,500 people, or 1,537 people, move to Licking County each year. Okay, number 4 says use the regression line to predict the population in 2015. So that means we're going to use our line and we're going to plug in 15 for x. So we're going to have 15, sorry, no, we're going to plug in 2015. 1537.24. We'll plug in our year 2015 minus 2926477.8. Okay, we can put this in our calculator. Okay, so we're estimating that in 2015 we'd have 171,060 people. That's 0.8, so, you know, depending on how closely you want to round this. $171,060.8. Okay, then number 5 says use the regression line to predict when it will reach 250,000. So to do that, we're going to set our regression line. X minus 2926477.8 equal to 250,000. And we're going to solve for x. So we would take 250,000. We would add the 2926477.8. Okay, and then we would divide by 1537.24. And we would estimate that in about the year 2066, the population would reach 250,000 if it kept growing at this rate. Okay, now we're going to do one more where we use a quadratic regression. So here we have some data off of timeanddate.com, and it says the length of day in Columbus, Ohio, for different times of the year. So this, each month, you know, 1 is January, 2 is February, and so on. And this was the length of sunlight, the length of day in minutes. Okay, so we're going to put this, remember to go put it in your L1 and L2. We're going to go to Stat, Edit. We're going to clear out what we had in there. So So we're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll put our values in here. 563, 610, 730, 62, 36, 890, 897, 854, and 782. Okay. Now, if we look at the plot of these, so I'm going to hit zoom stat again so it goes to these new values. We see that this doesn't really go in a line, it goes in something that's more like a quadratic, okay, a parabola. So we are going to hit stat calc quadratic regression number 5. Okay, and now it gives us something for A, B, and C. So the A is going to go in front of our x squared. So here our quadratic regression is y equals negative, we'll round to 2 decimal places, 10.73x squared plus 141.77x plus 400.17. Okay, and it says how good is the fit? Now here we don't have an r value, we just have an r squared, which works the same way. And since r squared is 0.95, we would say good. Okay, and then the last part asks us, it says use the quadratic regression to predict the length of the first day of November. And so November is month 11, so we would put 11 in for x. So we would have negative 10.73 times 11 squared plus 141.77 times 11 plus 400.17. Okay, so we would predict that the length of the day would be 661.31 minutes. Okay, so those are the notes for section 2.5.